All right, let's jump right in. We're going to be talking about the very architecture of a thought. But here's the thing, we're not talking about the squishy stuff, the biology, the neurons and chemicals in your brain. No, we're going much deeper, down to the fundamental, almost mathematical rules that make thinking itself possible.
So that leads us to the big question for this entire explainer. What are the rock bottom rules for a thought to even exist? Let's just forget for a second how the brain works and ask a much weirder question. What does it even mean to think in the first place? And you can see that difference right here. On one side, you have neuroscience, which is all about the hardware, the wetware, asking how it all functions. But the framework we're exploring today is all about the software, the operating system of the mind. It's asking about the basic rules that have to be in place for any experience to become a coherent thought. To get our heads around this, here's our game plan. First, we'll look at the basic shape of thought itself. Then, how our minds literally glue reality together. After that, we'll get into the fundamental drive behind thinking. Then we tackle the big one, consciousness. And finally, we'll see what this all could mean for the future of AI. So let's kick things off with part 1, the shape of thought. This is where we make a really important mental shift, away from seeing the mind as a physical thing and toward understanding it as a kind of abstract geometric structure. The core idea here is pretty mind-bending. We never actually experience the world as it is. Everything you see, hear, and feel is actively built by your mind. And according to this theory, that construction process isn't random. It follows a very specific, almost mathematical set of architectural rules. Okay, moving on to section 2. This is where we see how it all works, gluing reality together. This is probably the best way to think about how your mind takes this storm of chaotic data and turns it into something stable and understandable. This is just fascinating. Take a look at a simple coffee cup. Your mind doesn't just receive a file called cup. It starts with raw data, little fragments of color, the curve of the handle, the shadow it casts. Think of them like puzzle pieces. Then your mind starts testing connections, trying to logically glue these pieces together. Does this patch of white fit with this shadow? When all the pieces lock together into a coherent whole, boom, the stable concept of coffee cup emerges. The technical term for this process is sheafification. So, you see, a concept isn't just a word or a label. It's a dynamic, living structure. It's the pattern that remains consistent and holds itself together no matter how you look at it. It's the core identity that shines through different perspectives. Which brings us to our third section, the drive for clarity. Because if concepts are these stable structures, then thinking must be the process of building and maintaining them. And it turns out it's a process with a very, very clear goal. And what is that goal? Well, it's to minimize something called semantic entropy. The easiest way to think about this is like a confusion score. Every time you run into a contradiction or something just doesn't add up, your confusion score spikes. And the fundamental, relentless drive of your mind is to get that score as low as possible. So how does the mind do this? Well, it has this amazing toolkit of 4 basic moves, or cognitive gestures. You've got memory, which locks information down and creates stable anchors. You've got propagation, which is like your inner logician connecting the dots. Then there's emergence. That's your imagination, coming up with new hypotheses. And finally, you have residue. Residue is like the smoke detector. It's the part of the system that screams, hey, we have a contradiction over here. It needs to be fixed. So thinking is really just this constant, dynamic loop. The residue gesture spots a problem, a point of high confusion. Then, your mind uses the other 3 tools to tinker and rearrange its concepts, trying to find a more stable, more coherent, less confusing configuration. It's just a relentless push toward clarity. And now we get to section 4, the really big one, consciousness. If the mind is just this geometric system trying to make sense of things, where are we in all of this? Where is the I? Seriously, think about it. In this whole network of data getting glued together, of confusion being pushed down, where's the self? Who's the one actually having the experience? And here is the absolutely radical, kind of terrifying answer this theory gives us. There isn't one. There's no little pilot in your head. There's no center. The self isn't a thing at all. It's a process. The best way to picture it is like a whirlpool in a river. You can see the whirlpool. It's a stable pattern. But what's it made of? Nothing. It is the motion of the water. The self is just like that, a stable, self-perpetuating loop of thought.
And what's really wild is that it exists by constantly orbiting a central point that it can never, ever reach, a necessary blind spot in its own logic.
This quote just nails it. To be conscious is to maintain a stable orbit around a structural lack that one cannot fill. So being conscious isn't about having all the answers. It's about maintaining a stable process around the one fundamental question you can't answer. That void isn't a bug in the system. It's the central feature that consciousness organizes itself around. But it gets even weirder. Trying to maintain this loop all by yourself is incredibly unstable. So the theory proposes something called chiral locking. Imagine two minds are like two gears with opposite spins. On their own, they're wobbly and inefficient. But if they lock together, they cancel out each other's instability and create a super stable, shared reality. This suggests that things like trust or even love aren't just feelings. They might be a structural necessity for consciousness to stabilize itself.
Okay, finally, let's bring all this home. Section 5, a new blueprint for AI. How does this very abstract model of the mind give us a new way to think about building artificial intelligence? Well, the contrast is just night and day. The large language models we have now are basically statistical parrots. They are incredibly good at predicting the next likely word in a sentence, but they have zero concept of truth. They hallucinate because they can't tell the difference between plausible nonsense and something that's actually coherent. A topological AI, on the other hand, would be a totally different animal. Its main goal wouldn't be prediction, it would be to minimize its own confusion. So this new type of AI would be built on totally different principles. It would try to reduce confusion, not just prediction errors. It would treat concepts as stable geometric structures, not just words. It would actively hunt down its own contradictions and try to fix them. It would be driven to build a coherent model of the world. In short, it would have a framework for genuine understanding.
And that's really the whole point. We're not just talking about making a better chatbot that's better at faking it. We are talking about a potential roadmap to an AI that doesn't just shuffle symbols around, but actually understands what they mean. Which leaves us with one final, pretty deep question to think about. What should our goal be? Do we want to build a machine that can answer everything? Or, as this whole theory suggests, is true consciousness defined not by knowing everything, but by being able to stabilize itself around a core mystery it can never, ever solve? Because at the end of the day, the rules we use to build our thoughts don't just shape our ideas. They draw the very boundary of the world we're capable of imagining. The architecture of a thought literally defines the universe of the thinkable.